Ladies and gentlemen, welcome back to math. Today we are starting a brand new unit. The unit that we are starting is called trigonometry. Trigonometry. And trigonometry has to do with these little guys right here, a triangle. Now, um, we already know how to deal with triangles in a certain way in this class, but I'm going to show you a way to deal with them in a slightly different way. So we should know if I have a right angle triangle here, which means that that angle right there is 90 degrees, right? The measurement of that angle is 90 degrees. Then I should be able to find the side lengths of this triangle if I know, for instance, that this side length is 4 centimeters and this side length is 3 centimeters. Well, then this side length I can find. And we find it using, this is review, Pythagorean theorem, a squared plus b squared equals c squared. I take the square of 4, I take the square of 3, I add them together, and I take the square root of that and I get x. And so I'm not going to go through and do that because we've done that 1,000 times. There's an example I will go through eventually with that. But we'd find that this side length actually would equal 5 centimeters. So that's the side lengths, the actual measurement of the length of each side of the triangle. Okay. What we're learning now is we are going to actually learn about the angles on this angle right here, or potentially this angle right here in this triangle. So if we have one of these angles, let's say I know this angle and this angle is like 30 degrees. And let's say I know, I'll get my eraser here. Let's say I know that this side length is 3 centimeters. Okay, so I have this angle and I have this side length, but the question maybe asks me now for this side length. What is the side length there? And that's all the information I have. I have this angle and I have this side length. Well, guess what? You can actually use what's called a trigonometric ratio, or for short, a trig ratio, to figure that out. We can find the side length if I have the angle or the side. In fact, if I have one angle, this angle here or that angle there, and one side length, then I can solve the whole triangle for all of the side lengths. Let's call that one y and this one x, for all of these side lengths, okay? And the trig ratios that we have, you might have heard of them. You've seen them maybe on your calculator before. It is sine, cos, and tan. All right, so that's a little bit of an introduction to what trig ratios do, and I'm going to take you through a bunch of examples to get you comfortable with using them. All right, so let's talk a little bit more specifically about these trig ratios here, okay? I'm just going to erase some of this. So for my trig ratios, the first ratio that we talk about is sine. Let's do it in red. The sine of my angle. And what I'm going to say is that this symbol right here is called theta. Okay, it's just a Greek word for that symbol. And that symbol always represents an angle. Always. And so this angle right here, whatever this angle is, remember I said it was 30 degrees before, that angle is represented by theta. Okay, and sine as a ratio, remember a ratio is just a fraction. The ratio is the side opposite to my angle divided by the side that is the hypotenuse. Now let me explain that a little bit. The side opposite to the angle, so here's my angle that I'm looking for. The side opposite to that angle is the side across. That side is opposite. And then the hypotenuse, the side that is the hypotenuse, is always the longest side in the right angle triangle. That's the hypotenuse. So I would take the length of this side divided by the length of this side, and that would give me my ratio for the sine of theta. So like if this was 3 and this was 5, as like distance, 3 centimeters, 5 centimeters, that triangle, the ratio for the sine of theta, I'm just going to write it down here. The sine of my angle, or the sine of theta, would be 3 divided by 5. That is the ratio, the sine ratio, 3 over 5, okay? Okay, so if I wanted to then change it up just a little bit, so let's say I want to talk about a different angle. Let's talk about, oh, come on, my eraser's not working. Let's see here. There we go. So for sine, if I wanted to talk about this angle right here now, so let's say we know that that angle is 30 degrees, but we wanted to use sine to figure out that angle. Well, the ratio still applies, the same ratio, the side opposite to the angle applies, divided by the side of the, that is the hypotenuse. And so the side opposite now to this angle actually becomes this side right here. That is now the opposite side to that angle. And the hypotenuse is still the longest side. The hypotenuse, guys, never changes. It's always the side either across from the right angle, the 90-degree angle, or the longest side. They're the same thing. So now I have this angle, and the sine of this angle will be the side opposite, which would be this one, this length right here. Let's call it 4 centimeters, and divided by the hypotenuse, which is 5 centimeters if we're using our example triangle. So even though we had this side, which was 3 centimeters, this side doesn't apply to the sine ratio that we're using now, okay? So for sine, if it's this angle, the opposite would be here. If it's this angle, the opposite then, if it's this angle right here, the opposite then comes across, okay? I hope that's clear. Of course, if you have any questions, you need to ask me. But I'm going to give you another example. Oops, let's undo that. Because we're going to talk not only about sine, we're going to talk about cosine as well in this lesson, okay? So the cosine, let's talk about cosine of theta. The cos of theta, this is the second one that we're doing over here. That ratio is the side, what's called adjacent to the angle, divided by the hypotenuse. So if I'm talking about this angle right here, theta, that's the angle in the triangle that I don't know, but I know like this side length, let's say it's 4 centimeters. I know this side length, let's say it's 3 centimeters. And I know this side is 5 centimeters, but I want to find the angle. I can use the cos ratio, the cos of theta. So the cos of that angle is the side adjacent. Now, adjacent is right beside the angle. Okay, so the angle's right here. The adjacent side is right beside the angle. The hypotenuse is always, of course, the longest side. So that's still the hypotenuse. Think about what the side opposite would be to this angle for a second. What is the opposite side then? Well, the opposite side would be across here. That would be the opposite. And we don't need to use that side in this case because we are using the cosine ratio, okay? So the cosine ratio is the side adjacent, which is 3, divided by the hypotenuse, which is 5, okay? So that's the difference between sine and cos. Sine is the side opposite, divided by the hypotenuse, and cos is the side adjacent divided by the hypotenuse.